Osmunda. Osmunda is a very common fern, though cosmopolitan in distribution. Osmunda is found abundantly in South and Southeast Asia, where it has been used as a traditional cuisine across many Southeast Asian countries. Osmundine, obtained from the roots of Osmunda, is a very common potting material for epiphytic orchids. Hello friends, I am Dr. Ayantika Das, and in this video I am going to discuss about Osmunda. The video will be in two parts. Here in this video, the first part I will be discussing an overview, morphology, anatomy, ecological and economic importance, as well as the fossil forms closely related to Osmunda. In the next part of the video, I will be discussing about the reproduction and life cycle. This video is in the MSc syllabus of various universities. So let's begin the video. Taxonomic position of Osmunda. Now Osmunda belong to division Polypodiophyta, Polypodiopsida. Now this division and class, they are common to all the ferns, and Osmundalis, the order Osmundalis, they contain all the leptosporangiate ferns, and in fact this type of Osmundalis order, they have very characteristic, the sporangia, they are born on naked fronds. They do not have they are born on fronds that are non-laminar, that is they are not like the usual regular vegetative fronds, they are non-laminar, which means that there will be no indusium or even the false indusium. So this Osmundalis, they have actually naked sporangia. The sporangia is unprotected. Here in this picture we see these are the non-foliar leaves, the fertile leaves that bear spore. Here if you just zoom in, you will be able to see that the sporangia, they are born in a row. Here the sporangia, they are born in a row along the non-foliar leaf. So these are the non-foliar leaf, this one, and these are the foliar leaves. So this is a characteristic of Osmundalis, that is they have dimorphic or holodimorphic type of leaf. Which means that there will be a separate sterile and fertile leaf. There can be also a single leaf where the pinnules can be sterile and fertile. So this is a characteristic of Osmundalis. Now the Osmundaceae family. Osmundaceae family, they have very large sporangia and the spores are trilete. And the sporangia, they dehisce when there is a sporangia. For example, this is the sporangia, and they dehisce at the top, which means that the annulus, the uni or biseriate annulus with thickened wall, they are present in this region. So they dehisce by splitting at the top, and the spore are liberated, and the spore on liberation, they germinate to form a green cordate gametophyte that lies over the surface of the soil. So the ectoploid siphonostele is also a characteristic feature of Osmundalis. While we study fern, we should be very careful about the stellar configuration, because most of the questions from anatomy, they are based on the stellar organization in case of pteridophytes, because pteridophytes are the first plant to have proper vascular system, the bryophytes, they have hydroids. They do not have a true vascular system. So while studying various ferns and other pteridophytes, we should be very careful about the stellar organization, remembering the stellar organization. So, Osmunda, they have inhabited by habit, they are deciduous, which means that during the dry season, their leaf fall. And this is a herbaceous fern and grow in clumps, and they are very robust and can reach great height like 6 inches in height. They are not tree ferns, they are not tall as the tree ferns, but for the smaller ferns 6 inches is also quite high. About the habitat. So this is a terrestrial fern and mostly found in moist places, that is the moist woodlands, in the bog area, the riverine as well as the stream bank. And in it, though it prefers very wet soil, but just because it is a very robust species, it is a robust species, so it can tolerate sunlight. Also, condition is that there should be high amount of water or humidity in around or also in the soil. So during the dry season, the leaves turn deciduous and the rhizome, they lie dormant. And though they grow in all type of soil, they prefer acidic soil. So this is all about the habitat. So in India, we find a large number of Osmunda species, especially in the Himalayan region at a great altitude, and globally also it is cosmopolitan except few places. See, in the it is found in Osmunda is found in Asia, it is found in Africa, it is found in Europe and in the New World, from Canada, from the here to even Argentina, that is here. So we see that both old world and new world we are finding distribution of Osmunda. About the morphology, so plant body is divided into rhizome, leaf and root. As a rule, the rhizome, it is either upright or it may be subterranean depending upon the species. But the rhizome, very characteristic feature is that rhizome is not covered by any uniseriate or biseriate hair or ramenta, but instead it is covered with the leaf bases which is sclerotic. This sclerotic leaf bases, they provide support for the rhizome, and this sclerotic leaf bases are persistent. So the rhizome here is usually they are unbranched, but when they branch they have a dichotomy, and the leaves, they are spirally arranged. So we see here in this diagram, we see that this is the rhizome and this is the persistent leaf base. This one, it is the leaf base, and these are the advantageous roots. And we know that in ferns the primary root is soon replaced by advantageous roots, and here we see and that the roots, they, not here it is shown, but usually the roots, they grow two in number from the base of the leaf. So if this is the leaf base and this is the rhizome, so from here each leaf base we are finding that two roots are formed. So each leaf base, from each leaf base arises two root. About the leaf, we see that this is a monomorphic leaf where the single frond is containing dimorphic pinna. This particular pinna here, it is the vegetative pinna or the sterile pinna, and this is the fertile region. So this we see that this vegetative pinna, they are foliar, whereas the fertile region is non-foliar. This is the example of a monomorphic leaf. This is also the example of dimorphic leaf, where this particular leaf is a sterile one and this leaf containing the sporangia is the fertile one. The fertile one containing the sporangia, they do not have any lamina.
In the diagram,
Leaf lamina
in the
is
earlier
absent,
slide, we have seen that two type of leaves, that is unipinnate, that is one type of pinna, and bipinnate, that is two types of pinna that we have seen in the earlier slide.
This fertile
Generally,
so this
the
is
length
the
of each pinna
vegetative
is
pinna.
this much, and
This one.
the leaf, it consists of a rachis and the pinna, and the rachis is covered by glandular hairs, which is common in many of the ferns. The rachis is covered with glandular hair. And about the leaf, this we have earlier also said that the leaf during dry season they turn deciduous and the rhizome remain dormant. So the leaf bases, that is which is persistent, they form a mechanical support around the rhizome. And about the pinna of the sterile leaf, they are very leathery in texture and also they are covered by brown hair, just like the rachis. This one is the rachis, and these are the pinna. You see, these are the pinna, and these pinna are also covered by hair, which is present in this rachis. So the venation here, about the venation is dichotomous, which means that venation will be like this, again there will be dichotomy. So by repeated dichotomy, they have a reticulate type of venation. And about the juvenile leaves of the fertile leaves, they form a circinate vernation. But if we see the fertile if we see the fertile leaf do not have this type of vernation, circinate type of vernation. This is the species which has got
erect.
dimorphic leaves. We see these are the fiddleheads of vegetative plants, vegetative leaves, that is the sterile leaves. These green are the sterile leaves, and these sterile leaves we see they have a pinnately compound leaf with pinnate leaves, and this golden brown colored these fronds, they are the non-photosynthetic spore bearing fronds. They do not have lamina, and the main difference we see both in morphology as well as function. The fertile leaves, their main function is for reproduction, while as the sterile leaf, their main function is photosynthesis. This is then this diagram, this one here, these are the fiddleheads that are the young form of the sterile leaves. The fertile leaves, they are born just like erect, straight, even in young condition. And very close up of this dimorphic leaf, you see the here the sterile leaves, they have got pinnas, and the fertile leaves we don't see any pinna, just the division. This is the rachis, and these are the veins on which the sporangia are born. So the sporangia are born directly on the veins without any indusia or false indusia, because there is no pinna. The sporangia, it is naked, and as because they do not have any leaf, or so there is no indusia or false indusia, so the sporangia are naked. And this type of leaf, we know that they are deciduous, so early spring the sterile leaves, these are formed, and
sterile leaves. Before the sterile leaves are formed, the fertile leaves appear. So the fertile leaf, these are the first to appear, and these are the second to appear. So the sterile leaves, they appear after the fertile leaves appear. So this is the monomorphic leaf, where a single leaf contains both sterile and fertile region. These are the vegetative region, the sterile region. These are the fertile pinnules. These are the fertile pinnules. So here we see that there is no distinction between two type of leaves, but there is distinction in the type of pinna, and the position of these fertile pinnules, they depend upon, they may be upon species, they may be located, the sterile pinnules may be located at the base, they may be located at the tip, they may be located at the middle portion of the leaf. The Osmunda rhizome anatomy. Well, if you look at this diagram, here in this diagram, we see that it has got an irregular outline. And in fact, the outer epidermis, this is the outer epidermis, and this is the cortical region, this one. And these are the persistent leaf bases. These are the persistent leaf bases, and that these leaf bases stay even when the leaf, they are which are deciduous, the leaf fall, but the leaf bases remain. So this is the irregular outline, and this one here, it is the epidermis. Here this one is the epidermis. This is the cortical region, and inner to the cortical region is the endodermis. This one is the endodermis, and the cortical region is also outer cortex and inner cortex. The outer, it is sclerotic, and the inner, it is made up of thin-walled parenchyma. So inner to the cortical region is this endodermal region, the rhizome, and in the inner to it is the stellar region, irregular shaped. It is an irregular shaped stellar region is the pith region, and which is this is the cortex. We in the extracorticular region, we see that they have a horseshoe shaped leaf trace, which has again inside the horseshoe shaped leaf trace there is a horseshoe shaped xylem. But in the inside the corticular region, that is inside the stellar region also, we are seeing this type of vascular bundle. So the vascular bundle, both extracorticular vascular bundle in the leaf trace as well as the vascular bundle in the main stellar portion, they are this horseshoe shaped. This is the xylem portion. This is the xylem portion, and which I am denoting by X, and the inner to the xylem portion, it is the parenchymatous pith, and outer to the xylem, this layer, this is the endodermal region, and outer to the in between the endodermal and the xylem, this region, it is the phloem region. This region is the phloem region. The outer, this is the corticular region, this region. So we see basically the xylem is horseshoe shaped. It has got inner parenchymatous pith, outer phloem. And when the Osmunda is very young, it is protostelic. But later on, as the number of leaves goes on increasing, mature portion of Osmunda rhizome, it shows an ectofloic siphonostele. Xylem strands in the cortical region.
This is the xylem vascular strand in the extracorticular region, and these are the vascular strand inside the stellar region. So we see all are horseshoe shaped. So the number of xylem strand in the stellar region, it varies according to the number, according to the species. It is different number in different species, and it is always this type of xylem, that is inner horseshoe shaped xylem, and the outer portion is phloem. And in this way, inside the xylem phloem region, this is the pith region. This is the pith region, which is mostly parenchymatous in most of the Osmunda, but in certain region there is an mixed type of pith, that is sclerenchyma and parenchyma. So by default it is
the leaf anatomy.
parenchyma.
We
In
see
some
these
species
are the
we have a mixture of
these are the sterile
sclerenchyma
leaf.
and
This
parenchyma.
this is the fertile leaf. This is the fertile leaf. And we see, though the normal leaf, the normal sterile leaf, they have an outer, their pinna, they have an outer epidermis, and the inner, this region has got mesophyll tissue, and this I'm drawing it in yellow. So the mesophyll will again contain this horseshoe shaped xylem, and the outer to it is the phloem. So this is the case of vegetative leaf, but this is the this is the sex organ bearing, that is sporangia bearing leaf, where we see that these are the individual sporangia that is borne on. This is the rib, this is the main rib, and this is the side rib. This is the rachis, this is the rachis, and these are the side ribs on which the sporangia is born. The sporangia, we see that this is the diagram of a sporangia, and we see that these are the spores. Inner to it is the spores. These are the spores. And we see that this region is the annular region. This is the annular region with thickened walls, and inner also we see that there are spores still. So this is pretty much the leaf anatomy of even the fertile as well as the sterile leaf. Petiole anatomy of Osmunda. Now this is how the petiole looks like here. In this diagram, we see that it is almost circular in outline, and it has got a horseshoe shaped vasculature. And inner to it, in this region, there is the parenchymatous region. This is the xylem, the brown region is the xylem, and this is the phloem. And very close to it, xylem, there is also an inner phloem, which can be very easily seen here in this diagram. So basically, the xylem, the vasculature in the petiole is horseshoe shaped with xylem sandwiched between phloem, and this entire vasculature, it is covered by an endodermis, which is very prominent. And this type of vasculature, it is embedded in the cortical region. Economic importance of Osmunda. Osmunda, especially the fiddleheads of Osmunda. Fiddleheads are nothing but this immature, succinately coiled leaf, or the sterile leaves of Osmunda. These fiddleheads are used traditionally in cuisine of South and Southeast Asian country, especially in China and Korea. These fiddleheads are very tasty, like asparagus, and is not carcinogenic. Many
many ferns, especially Pteridium aquilinum is a fern that is known to have a very carcinogenic fiddleheads. But unlike that, we do not have such carcinogenic property associated with Osmunda. And Osmunda japonica, it is of immense ecological as well as economic significance. It is used as in bioremediation, in purifying the air, reducing the amount of toxins in air, especially the formaldehydes. So it is of immense ecological importance also. Many species like Osmunda regalis, Osmunda cinnamomum, Osmunda claytonia, their root are actually contain osmundine, and these osmundine is actually a very good agent for germination of orchids, and that is why it is used in propagating and growing orchids. Ecological significance. Now Osmunda species, they are a very good host plant for the various type of butterfly and moth larvae. Also, this Osmunda cinnamon fern, that is Osmunda cinnamomum, they form huge clonal colonies, and their massive root stock, they are also very good as a substrate for growing epiphytic plants apart from orchid. So also, this Osmunda's regalis, this is one species of Osmunda that has become very rare. In fact, it has been declared endangered due to the drainage of wetland for agriculture. So once we drain the boglands and do agriculture in that, these Osmunda regalis, it is becoming very rarer and rarer. Fossil forms of Osmunda. Now we know that this fossil form of Osmunda, it is dates back from Paleocene, and we also see it in the Jurassic age, and especially south of Gondwana land. We know that there is the earth has two pardon me for my drawing. So earth has, earlier they had a Laurasia and then they had a Gondwana. I'm not drawing it perfectly, but if this is the Laurasiana, this is the Gondwana land. So in the southern part of Gondwana land, we are getting these fossils of Osmunda, and especially this Claytosmunda, Osmunda verhi, Osmunda claytonites, these all they are actually found in permineralized fossil. Permineralization is a process when the organic matter is getting replaced by some mineral. Now permineralization can be by silicification, that is addition of silica instead of the organic matter. It can be pyritization, where iron and sulfur is getting introduced, replacing the organic matter. It can also be carbon. So this is the permineralization, and by this permineralization, fossils can be preserved. Actually fossils those are preserved are permineralized, and we see that all type of, from the new world to the old world, we find this fossil everywhere. And we see that this from the Paleozoic to the Mesozoic, we find this type of fern. Actually, this type of fern, they start during the Carboniferous period, that is this Carboniferous period, until the Jurassic period. So from Carboniferous to the Jurassic period, this can be found. So this was all about the first part of Osmunda, where I discussed the overall overview of the Osmunda, its geographical distribution, morphology, anatomy, the fossils, and its ecological and economic importance. And in the next part of this video, I will be discussing about the reproduction and life cycle of Osmunda. If you like this video, do share it with your friends and please do subscribe to my channel to watch more such videos. And those who have subscribed, thanks for subscription. And if you have any comments, if you want me to make any video, do write in the comment section and I will make videos on that. And those who have already written the comments, and I will be making videos on them one by one. And thanks again for watching this video. Please do maximum share, like, share and subscribe to my channel. Thank you again.